Hello students, in this video lecture we are going to see about synchronous sequential circuit. As we have already seen about combination logic circuit which do not have memory element, whereas in sequential circuit we will be having memory element. That is, it is a circuit to which storage elements are connected to form a feedback path. That is, our sequential circuit will be having a feedback path where we will be using a memory element in it, right? Now I'm going for the difference between our combination logic circuit and sequential logic circuit. If I say combination logic circuit, I will be having n input variables and a different n input variables and different m output variables. In the same way, sequential logic circuit is same as that of our combination logic circuit, but only difference is this section. That is, our memory element will be present in our sequential logic circuit. That is, the definition says the output depends only upon the present input variable, whereas in this case output depends upon present input and also past input. That past input is because of the memory element what we have. In combination logic circuit we are not using memory element, whereas in synchronous sequential circuit we are using memory element. Example is adder, subtractor, what we have seen already, and register counter which we are going to see later on. So now we are going to storage element. As I said earlier, we need to store some values. So now we have to study about this storage element. This latch and flip-flops are the basic storage element, whereas this will store 1 bit data to it, right? So now the difference between latch and flip-flop should be known. Operation wise both are same, only difference is that the latch, as soon as you give input you will be getting the output in your latch, whereas in your flip-flop we will be having separate pin which is known as clock. If at all you give input, output will not, you will not have change in your output. When you give your clock pulse, that is, if you are giving trigger from your clock pulse, you will be getting the output. That is the difference between your latch and your flip-flop. Now I'm going for the first latch. Totally we have 4 kind of things: SR latch, D latch, JK and T. Right? Now we are going for SR latch. As the name suggests, S is for set and R is for reset. Now the construction, we will be using 2 NAND gate or 2 NOR gate. That is, 2 NOR gate will be cross coupled to each other. I'll show you the circuit diagram. This is the circuit diagram. That is, one of our output is given back as input to this, and in the second case also we have giving the input to this. This is the gate level diagram, and this is the logical symbol what we have. Now the operation of this, how this will work. I'm just going to the operation directly. When I give a set is equal to 1, it is going to store 1 bit data to it. That is, I'll repeat, this latch is going to store 1 bit, SR latch is going to store 1 bit data to it. That is, it is going to hold 1 or 0. At any given time, it can store a value 1 or a 0 to it. That is, now if I'm showing you S, R is the input, Q is the output, Q bar is always the complement of our Q. Q bar is always complement of our Q. Right? Now if S is equal to 1, if S equal to 1 and R is equal to 0, then we will be getting Q is 1. When set is 1, automatically the value is set. In the same way, when both the values are 0, 0, then we will be having 1, 0. That is, previous value will be stored in it. Previous value will be in memory to it. Now I am going for the next condition. That is, if it is 0, 1, right? When R is 1, which R is nothing but reset, S is equal to 0, then our Q is becoming resetted. Right? In the same way, when S is equal to 1 and 0, 1, 0 will give the value 1 to your Q and 0 to your set. The important thing to be remembered in our SR latch is that you should not give 1 and 1. If you are going to perform both set and reset operation, the output is don't care. That is, we cannot predict the output. Hence, I have mentioned with the name forbidden. So I'll repeat what is set. 1, when s is equal to 1, it will be setting the value. When r is equal to 1, it will perform reset value. When it is s and r are 0, 0, it will perform memory value. Now we are going for delatch. Delatch uses NOR gate. We have a forbidden state. If we are going for SR latch, we are having the forbidden state. To avoid that, we are going for delatch, JK latch, all other latches. In delatch is also known as transparent latch, where this is the construction where with SR latch I have constructed a delatch in this. That is by interconnecting S and R to it. If my S value is given as 1, automatically my R value will become 0. If my R value is becoming 0, automatically S value is becoming 1, and S value is 0, automatically R value is becoming 1. Now let's go for this table. That is, if enable is 1, it will get the input from SR. If enable is 0, it will act as memory. Simple concept. That is, if enable is equal to 0, it will act as memory. When D is equal to enable is 1, it will get the input. When D is equal to 0, automatically it will perform reset operation. 0, this will become 0. The same way, if D is equal to 1, this will become 1. This is the reason why it is known as transparent latch. Whatever is given as input in your D will be output in your Qn plus 1. Now the same concept I'm going for flip-flop. Only difference is that I have one more input signal, which is nothing but clock. That is, in the SR case, SR latch case, if you give both the input, you will get the output. But when you are going for the flip-flop, if you give both the input, no change will happen. It will wait. When you give your clock pulse, then only your input will be taken. Now I am going for triggering in flip-flop. As I told you, this clock pulse, there are different types of triggers. Let's go for the triggers. Flip-flop is switched by the momentary change in the input signal. This momentary change is called the trigger. The clock pulse, clock input, what we are going to give is known as triggering. These types of triggering are level triggering and edge triggering. This level triggering is again classified into positive edge triggering and negative edge triggering. This edge triggering is again classified into positive edge triggering and negative edge triggering. These are all the diagram where this is positive edge, where it will work. Flip-flop will get switched on in this position, in this position. If it is negative edge, flip-flop will get switched on in this position and this position. Now we are going for negative edge, whereas at this point, this positive edge point, our flip-flop will be triggering. In the same way, at this edge point, that is from 1 to 0, the point where your flip-flop will reach from 1 to 0, this point will be your negative edge triggering. Now we are going for types of flip-flop. There are 4 types of flip-flop. They are SR, JK, D and T. So this is our SR flip-flop, where this is the block circuit diagram, where S, R, clock, this is the circuit diagram. This we have already discussed. That is, for 0, 0, it will act as memory. For 0, 1, it will perform reset operation. For 1, 0, it will perform set operation. For 1, 1, it is going to be indeterminate, forbidden or not used state. Now this is the characteristic table of SR latch. This characteristic table is very much important when it comes to analysis purpose. I will repeat, when we are performing any analysis, this characteristic table is very much important. The same process what we have done already, that is, when it is 0, 0, this is your present state, this is your next state. 0, 0, both are going to be 0. Present state is 0, hence it is going to be 0. When it is 0, 1, as your present state is 0, as it is 1, it will make your next state is also 0. When it is 1, 0, now my present state is 0, present state is 0. When S is equal to 1, it will R is equal to 0, it will perform set operation. That is, my next state will be 1 here. And we are forbidden to use S is equal to 1 and R is equal to 1. Now let's see how to find the characteristic equation of this. As this is Qn, S and R for the value where I have 1. I have 1 for 2, and don't care for 3, then 1 for 4, then for 5 and 6. 5 will be 1 and 6 will be don't care. I have mapped everything in my K map, and I have done my 4 variable K map, 4 variable combination and 2 variable combination. So this is my SQN plus 1 is equal to S plus QNR is the equation of your SR flip-flop. That is, this is the tabular representation where this is the Boolean expression equation. I have represented it in terms of Boolean equation. Now I am going for JK flip-flop. J will perform set operation or JK flip-flop, whereas in J is going to perform set operation and K is going to perform reset operation. Now let's understand the reason why we are going for JK flip-flop. That is, in SR flip-flop we are having unused state. That is, for S is equal to 1 and R is equal to 1, we don't know what is the output we are going to get. To avoid that situation, we are going for JK flip-flop. In JK flip-flop, we have added operation. We have added operation. That is, for 1 1, it is going to perform toggle operation. Toggle operation means, say for example, if my present state is 1 and my J and K are 1 1 respectively, then the output, that is the next state, will be 0. That is, the present state is being changed to 0. That is the toggle operation. Now this is the diagram, whereas this is the same SR latch diagram what we had, and only thing is that I have coupled this Q bar and given to this AND gate. The same way I have coupled this and given to this AND gate, right? So now this is my diagram, whereas when J is equal to 0 and K is equal to 0, whatever is your present state, that will be your next state. That is why I have indicated it with Qn, that is no change. Now for J is equal to 0 and K is equal to 1, it will perform reset operation. That is, output will be, next state will be 0. For 1 0, it will perform set operation. For 1 1, whatever is your present state, say for example, if my present state is 1, that will become 0. The same way, if my present state is 0, that will become 1. That is the toggling operation will be done. Now let's go for the characteristic table, which is very much important for the analysis purpose, right? That is, I have written all possible combination. That's all. It is something similar to your truth table, whereas Q bar, J, K, 0, 0, same. 0, 1, it is going to perform reset operation. 1, 0, we are going to get present state is 0, and as J is equal to 1, it is performing set operation. 1, 1, let us look at this state. That is, for 1, 1, previous state is 0, as this is 1, 1, it is going to perform toggle operation. That is, the 0 is being made to 1 here. Now look here, when it is 0, 0, my previous state is 1, obviously my next state is memory, hence the same output is following. Is it clear? Now let's go for the equation, Boolean equation for your JK flip-flop. That is, now I have values for my 3, I am saying the min term, that is 0, 1, 0 is nothing but 3. This is, 2, 3, 4, and my 6 I have values. So I have mapped them here, and I have done the two-cell combination, the two-cell combination. With that two-cell combination, I am getting J Q bar plus K Q bar. This is my characteristic equation. Now I am going for D flip-flop, whereas in D flip-flop is nothing but combining S and R with a NOT gate. So this operation I have already explained. The same operation is going to get repeated here. So I am directly going to the characteristic table. See, look at this. Your D and Qn is exactly same. This is the reason why it is known as transparent flip-flop. Here you have 0, 0. That is, min term is 0, 1, 2, 3. With this, if you map, you will be having value for 1 and 3. So if you map this as Qn is equal to D, look at this. Qn plus 1 is directly equal to D. That is what is reflected in this. Now let's go for the toggle flip-flop. We can obtain toggle flip-flop by coupling J and K together. By coupling J and K together, we can obtain toggle flip-flop. As the name suggests, if the value is equal to 1, whatever is your present state will be toggled. I'll repeat again. If T value is equal to 1, if my present state is 0, then your output will be 1. If the present state is 1, your output will be 0. that is it will perform toggling operation. When it is 0, when t is equal to 0, it will act as memory. When t is equal to 1, it will perform toggle operation. So look at this case. When it is 0, toggle t is equal to 0, automatically same 0. When t is equal to 1, my present state is 0 here, that is being changed to 1 here. Now it is 0, so same 1 and 1 is getting followed. Now my present t is equal to 1. Now my present state is 1. As this is 1, it will make it to 0. So this is my table, truth table. Sorry, this is my K-map with this Qn plus 1. My characteristic equation is Qn plus 1 is equal to T Qn bar plus T Qn, T bar Qn. With this, I am completing the all types of flip-flops. Let's meet on our next video lecture.